Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about minimizing first-time fix rate with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes must be adapted to take advantage of these new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of these new capabilities and establish a true data-driven manufacturing culture. So today we're going to be talking about first-time fix rate, and we're going to kick it off by looking at the traditional approaches and what happens today. So why don't things get fixed on the first try? There are a lot of different reasons why, but we're going to focus on a few today that are very common. And to start off with, we'll look at, is the right repair person sent to the machine in the first place? And, this is very typical when you have people that are specialized between electrical and mechanical in your maintenance department, and you have a breakdown at a machine that, has both components to it. If you don't have any information from the machine or the operator, how do you know which one to send out? You're basically just taking a guess, sending someone out there and hoping it's the right person. And I've seen this at a lot of different companies where this happens. And usually the answer is that, well, we're going to cross-train our maintenance people so that they can take care of both types of issues. And I mean, that's certainly beneficial and, has its own, sort of rewards with it and so forth in terms of optimizing your people. But there's probably an easier way to go about this, which is if you just have some level of diagnosis at the machine, they can send information along with the ticket, but we'll get into that later. Let's see. So then, once the person gets out there, they may not be able to diagnose the issue on the first try. So they may need something else to be able to, meter the equipment or something else to be able to figure out what's going on with it, or it just may not be obvious what's happening with the machine. They may not have the right parts in stock. And so they go to fix it, but they understand what they need, but we don't have that spare in stock. And so it's going to have to wait until that part gets ordered before we can fix the machine. Or the right part is in stock, but they didn't bring it with them to the repair. And so now they've got to go to the storage room, get that spare, come back to the machine and make the repair then. Or it may just be, their repair tools that they brought to the machine with them weren't the right ones in order to actually make that fix. So a very similar problem, they just have to go back to the room where the tools are kept, grab the right tools, come back to the machine. Or they may need additional assistance, it may require engineering support, or it may require a second maintenance person, depending on the task and so forth. Or it may just be that they don't know how to make the repair. So they see the problem, but they don't know how to fix it, or they don't know which repair is required, et cetera. And so these are very common issues. And we're going to look at how to address each one of these. If you have additional ways that, machines don't get fixed, please enter them into the Q&A, and I'll answer those after the session. So what are the different systems that we can use to provide help, for these different issues? What are the technologies that are available with Industry 4.0 that can help address this? And I'm going to focus on 3 of them. The first one is the Industrial Internet of Things. And if you're not familiar with it, Basically, it is a network of physical objects, machines, sensors, etc., that are connected to either your own internal network or the internet. And you're using software to collect that information and to do things with it, whether that is the initial data collection, routing that information to different systems, or persisting that information to a data store, processing events, doing communication with that, alerts and so forth. Typically these systems provide development environments and, mashups or user experience builders. They'll often incorporate machine learning or AI systems, or at least have links out to those systems. And they're very, very extensible. And typically they provide very little out of the box functionality, but then they provide a platform for building pretty much any workflow that you want. The next technology that we'll take a look at is augmented reality. And augmented reality is basically providing an interactive experience of a real world environment kind of in the background, with information in the foreground about that process, whether that's instructions, statistics, or anything else. And we'll be seeing some examples of that today. And then finally, artificial intelligence, machine learning applications will help us to diagnose different issues, to provide classification for what's happening, and predictive capabilities as well. So with that background and with those different technologies in place and so forth, how is it that we can go about maximizing that first time fix rate? So what we're going to do is we're going to go through the different issues that we started off with. And we have kind of that list over here on the right side. And we're going to start off with, how do you send the right person instead of sending the wrong person? Well, the key to doing that is understanding the nature of the problem at the machine. As I talked about when we first went through the list. And if you can understand and diagnose what is happening at the machine, what you can actually start to do now is to pass that information along to the maintenance system, to, when you create the ticket, have that information along with it, so that the maintenance team has a good idea of what the problem is, and who is the right person to address that, and send the person with the right set of skills to the machine in the first place. And so what we're combining here is information from the process. Usually we'll connect like an IoT system to the different devices. We'll collect information from the process itself, process variables and status codes and fault codes and things like that. And we'll utilize those within a machine learning application to interpret that data and to classify the issue. So we're going to essentially do pattern matching that will help us identify what is the particular type of problem that occurred, and then integration to pass that information along to the maintenance management system. And so by combining these three different elements, now when we create that ticket in the maintenance management system, we can already have the context of what type of problem is occurring. And now we can, provide someone with the right skill sets to address it. So this is a very similar issue, but it's actually, once the repair person gets to the machine, being able to diagnose what the actual fault or root cause of the problem is, and then being able to do that on the first try. So the key to diagnosing that issue on the first try is to give the team as much support as possible. I mean, the maintenance people are generally pretty good today about being able to identify what those issues are, but how can we minimize the amount of time that takes, as well as making sure that we provide them support, so that in some of the more unusual cases, they still have the information they need in order to get that diagnosis done. And very much like the last example, what we're doing here is we're collecting detailed information from the process through an IoT system. We're looking at, again, the information coming from the PLC, whether that's the fault codes that got tripped when the machine went down, what was happening in the machine prior to that. So, what were different pressures and temperatures, what was the power draw? Did we have a power spike and so forth? And being able to, first of all, provide all of that information to the maintenance people so that they can see kind of that raw data, but then also passing that through, learning systems so that we can help interpret and classify that information as much as possible, so that we not only provide the raw data, but we provide that intelligent assistance as much as possible to aid them with the diagnosis of the problem. One key thing here is that if we've done something like an FMEA on the process, failure mode and effect analysis, then as we're doing FMEAs in this type of an environment, what we want to be able to do is to look at each one of those different failure modes. And as we look at the probability of detection and how we raise that probability of detection, what we want to do is to identify what are the signals from the machine that we would actually look for that would signal that that is the actual failure mode. And then if we have that knowledge encoded into our systems, we can utilize that to train these expert systems, machine learning applications and so forth, to be able to tie that information of what's happening in the machine when it fails, going through that analysis, tying back into that process, and actually identifying what are the right failure modes to call out so that we can let the maintenance people know this is the diagnosis based on what we've seen. The next thing is having the required parts in stock. And if you've ever been in the situation where, hey, we know what happened, but yeah, we don't have the right part in stock, so it's going to be 6 weeks before we can actually have this machine up and running again, then the pain here. And really, this is about a couple of different processes. First of all, you want to be able to have a good forecasting capability based on historical consumption of spares and so forth. And usually you're using forecasting capabilities here, such as the Croston's method, which looks at sparse data forecasting. And utilizing techniques like that, you can actually look at, what should we have in stock and do the cost benefit analysis for what's the probability of requiring this part versus how much it costs to actually keep it in stock versus, how long does it take to, get the part once we know that we need it. The second piece of this is if we have a predictive maintenance process in place, then we can tie the information from that predictive maintenance routine or application into what is the failure mode, what are the different failure modes that we're predicting at what time, and then what are the spares that we're going to require for that type of fix. Because then we can make sure that we have them in stock, and if we don't have them in stock, if we see something coming up and raising in probability of upcoming failure, then what we can do is proactively order the parts that are going to be required for that particular failure mode in advance. And that way, when it does fail, we have those in stock. And hopefully, if the predicted failure mode gets high enough, we can actually grab it before it fails. So, those are the different things that we can do to make sure that we're gathering all the information, doing our, requirement setting and so forth, so that we can have those parts in stock when we actually need them. The next one here is making sure that when the repairman goes out to the machine, that he brings the right parts that he's going to require, the right spares that he's going to require with him to make that fix. Because if you go out to the machine, you do the diagnosis, and then you say, I need something from stores. Now you have the repairman leaving the machine to go get the store or to go get the spares, have a chance to get interrupted, anything else. before it gets back out to the machine and makes that repair. Plus, you're just lengthening the amount of time that repair takes. So this goes back to some of the previous things where we were kind of doing that diagnosis in advance as much as possible. And we definitely want to do that so that, as the machine goes down, we're looking at that data. We're trying to do as much of the diagnosis automatically as we can, and including that when we create the ticket within the MMS. And if we do that, then we can also attach basically to that ticket that we're creating. And, here are the spares that are required to address this type of failure, or that are potentially required to address this type of failure. And then you can, bring those with when you go out to the machine to make that repair. And depending on the size and the layout of the facility, this can make a huge difference in terms of how long it actually takes to make that repair. So, the other side of this is that you can't make that determination in advance. Perhaps, when this failure mode occurs, there's only 30% chance or 20% chance that you actually need the spare part. And so the maintenance person goes out, they make that assessment, being able to have connected systems so that you can coordinate those maintenance activities with other material delivery. So if you have other parts delivery that's happening throughout the facility, integrating your maintenance team with those material deliveries so that you can have the people that are already delivering parts just deliver that spare to the machine, instead of having the maintenance person have to walk over to the spares department, get the spare, bring it back to the machine to do the repair. If they can communicate with the materials team, have them make that delivery, it can be done much more efficiently. So that's another way that you can optimize that. Very similarly, bringing the right tools to the machine. So, when you look at this process today, it's a different problem, but the solution is exactly the same. Essentially, you're going to be doing that diagnosis up front. You're passing that along with the maintenance ticket when you create it, and you add to that ticket not only what spares are required, but also what tooling is required in order to make that repair. And now you make sure that the maintenance person, when they go to the machine, has those tools with them. And so if you can do that, then you can minimize the number of times that the repairman has to leave the machine to go get a different set of tools. So I've mentioned, IoT and machine learning and so forth here, and I just want to take a little bit of time, since I've mentioned those repeatedly at this point, to give some examples. What I'll be showing here is software from PTC with ThingWorks, which is one of the different partners that I work with. And, in this case, what we see on the screen is, being able to monitor the machine, looking at the utilization, looking at the uptime and the downtime, what's actually happening within that machine and so forth, and being able to really get that detailed view of what's happening in the machine for performing all these tasks that we've been discussing. The next step with that is being able to tie directly into the details of the process variables and so forth with that machine, not only looking at the status of it, whether it's up, whether it's down, grabbing high-level fault codes when the machine goes down and so forth, but also looking at some of those detailed process variables such as temperatures, pressures, power draw, etc., and being able to capture those and incorporate those into this kind of packet of knowledge that we're passing along when we create these tickets. And then being able to integrate that work cell, not only being able to provide that information to the operator, but now having that connection into the enterprise maintenance systems and so forth, and being able to pass that information in a way that you can automatically create the ticket, you can automatically pass this information into the ticket and so forth, and being able to provide visibility perhaps a link back into the system so that they can click on the link and see much more contextual information about what was happening on that machine prior to the failure. And then also, having those predictive capabilities, having the artificial intelligence, machine learning built into this, so that you can do that automatic classification, of different types of issues. You can utilize information and in your training of how you're doing that training and so forth from FMEAs that you've done in the process and so forth. And then also being able to actually do the predictive capabilities so that you can do that spares planning as well. Then, another reason that you could not get this fixed on the first try is that the maintenance person simply isn't able to diagnose the problem. And there are cases where neither the machine learning application nor the maintenance person can get that done, and you simply need engineering assistance. And so one of the capabilities that you can put in place to address that is remote assistance, and being able to have the smart glasses or just a cell phone, and being able to pull up an app that allows communication with the visual, so that the maintenance person can show the engineer what's happening on the machine, and the remote expert can provide assistance right there on the screen, highlighting different areas of the screen, what needs to be done, and so forth. And so, to give an example of that, you have a maintenance person out at the machine talking to a remote engineer, and that engineer is actually then highlighting different areas to look at and different things to take action upon, and showing what needs to be done in order to either diagnose and or fix the problem. And so kind of one last question that we had up front in terms of what goes wrong and why the maintenance can't get the machine fixed on the first try is that maybe they just don't know how to fix the machine, and maybe there's not an engineer available, or whatever. And so how can we provide work instructions for repair, or for a first time repair? How do we actually capture that? And so if the failure mode is identified as something that has been done before, what we can do is we can link to not only that maintenance management system to create the request and so forth through ticket, but we can also link to a digital work instruction system to guide that maintenance person through the repair. And so this can be done again through that augmented reality system with either the glasses or smartphone and so forth. And you can also provide an expert system so that anytime that a first time repair is performed, you actually capture the steps in doing that first time repair. And that way, if that repair has to be done again in the future, now you have that within the library, and you can automatically link to that based on the types of failures of diagnosis and so forth that was performed. And so an expert capture system allows you to capture those steps very easily, especially if you have the smart glasses in place, because essentially you're just kind of giving visual and auditory notes as you go along with the repair, and it's capturing that pretty much automatically. And so that way, now you have that link to that failure mode for the future, so that any future repair person, when they go out to the machine, can just follow along with the instructions to make that same repair. So with that, we've gone through all of our different reasons why you can't make that fix on the first try. If there are any other reasons why people have come up with that you can't make that fix on the first try, please go ahead and put them into the Q&A. In the meantime, if you have any other questions, or you want to reach out to me to talk further about this topic, or anything else around how you combine the smart factory and the lean factory, please reach out to me, Tim at Visual Decisions, 630-957-8096. And I look forward to talking with you in the future. I don't see any questions in the Q&A, so that'll do it for today. Thank you very much for your time, and I look forward to talking to you again in the future. Bye-bye.